All right, today we are going to continue working with our review topics in algebra, working with equations and expressions, etc. Now, adding and subtracting rational expressions is something that you did in Algebra 1, it's something that we did in geometry, and we're going to review it now. Now, the biggest thing is that if we have an expression, which means no equal sign, you can't clear the fractions. You must make a common denominator. So if we look at something as simple as 2/3 plus 3/5, the least common denominator is going to be 15. And I get that number because I know that 3 and 5 both go into, that's going to be your key words, go into 15. So I multiply top and bottom of the first one by 5 over 5, which is really 1. Top and bottom of the second one by 3 over 3, which is really 1. I end up with this, and remember when we add fractions, the denominator stays the same. Add or subtract the two numerators for a new numerator. And then we are going to leave as a fraction. And you can leave them as improper fractions, but we are not going out to decimals. So in general, those of you that kind of like the formula bit, if I have A over C plus B over D, what do C and D both go into? Well, I don't know, but I built 15 by simply taking the two numbers, the two denominators, times each other, so that should work. The least common denominator here, well, what does C go into? C goes into C. What does D go into? D goes into D. So if I multiply those together, both numbers go into it. Remember, denominators, common denominators are going to be bigger. Don't confuse it with a factor, a common factor. So in order to change A over C, I have to multiply top and bottom by D. In order to change B over D, multiply top and bottom by C. Now I have that common denominator that stays the same. Add the numerators, and because the variables are different here, I can't combine them. So least common denominator or least common multiple, those are synonyms. I will probably always say least common denominator, LCD. If I'm looking at 6b and 14a squared b squared, one of the things I can do is I can factor the coefficients, because I don't know what number 6 and 14 both go into. So least common denominator. If I look at the factors, I need both the factors of 6. So 6 will go into it. In order for 14 to go into this new number I'm building, I need both the factors of 14. So I need a factor of 2. Oh, I already have one. I need a factor of 7. I don't have one, so I'm going to multiply one of them in. I need a factor of b, so I'm going to multiply one in. I need two factors of a. Oh, I need two factors of b here, so I'm going to make sure I have 2. That is your least common denominator. So then, in order to make this work, I'm going to write my original problem here, 5a squared all over 6b. And actually, let's rewrite this as 2 times 3 so we can see what we're doing, plus 9 over 2 times 7 times a squared b squared. So what am I missing out of this? What am I going to multiply each one of them so that the denominator transforms to this new thing? Well, I have the 2 and the 3, so I'm going to need the 7. I have 1b, so I'm going to need one more b and the a squared. What do I need over here? I have the 2. Oh, I'm going to need the 3. I have the 7. I have 2 b's and 2 a's, so this is all I need to multiply by. So multiply the numerators, and I'm going to get this new denominator. I'm not really going to worry about multiplying it together yet, because remember, after we do this, we're going to see if we can combine like terms and do any factoring and simplifying. So I have 5 times 7 makes 35. A squared times a squared is a to the 4th, and b. And that's going to be plus 27. Do I have a greatest common factor? Any factors in the numerator? I do. I have a common factor of 7, so I'm going to factor that out. Oh, I'm sorry, I don't have any common factors. I was misreading my writing. And so since I don't have any common factors, I am done. And that is my answer. And if you want to go ahead and clean up the numerator, we could do that just so it looks a little prettier. So I have 42a squared b squared. So let's repeat the process over here. Now when I look at 2 and 12, it's pretty clear that they both go into 12. Y and y squared both go into y squared, and x goes into x. Another way to think about this is you always need the highest power of the exponent. So if I go to my original, and then I'm going to go back and say, well, what do I need to multiply this fraction by to make this denominator? Well, I'd need to multiply it by 6yx. That's what I'm missing. So again, if you want to factor 6 times 2 so you can see what 12 is, that's fine. In here, I have 12, so I don't need to worry about it. I have y squared, I have x. I actually don't need to multiply by anything. It is the common denominator. So I'm going to clean up this one. So I have 18yx cubed all over 12y squared x plus 5 over 12xy squared. And if I write this as a single fraction, actually do the adding, plus 5 all over 12y squared x. Quick check for common factors. Do 18 and 5 have anything in common? No. I'm in lowest terms, and there is my answer. So, polynomial denominators. So what happens if I have expressions in the bottom, if I have x terms and constants? So number one is we always factor. You need to break those expressions down into lowest terms. Then you're going to figure out your least common denominator, and then you multiply and add just like we were doing. So if I go ahead and factor these things, I have x plus 10 all over greatest common factor 3 times x minus 5. Now if I have a minus, remember these are single terms in the numerator, I like to change this to plus a negative 1 being multiplied, and then I'm sure that I won't drop that negative. And so I'm going to just leave the denominator alone for a minute. All over common factor between 6x and 30 is 6, and I have x minus 5. So now I need to figure out what is my least common denominator. Well, for this denominator, I need a 3 factor, and I need an x minus 5 factor. When I look at the next one, I need a 6 factor. Well, 6 is really 2 times 3. So if I throw another factor of 2 over here, I now have my 6. I already have an x minus 5 factor. So that is my least common denominator. So now I'm going to go ahead and multiply this first fraction times what I need to make the least common denominator, which is going to be a 2. Top and bottom is all I'm missing out of my factor list. Plus, I've got this negative 1 times 3x plus 15. And here I have 2 times 3x minus 5. That is my common denominator, so nothing is going to change over here. I have a common denominator, so I'm going to go ahead and do the distributive property to both of these and combine them as a single fraction. So my denominator stays the same, and my numerator becomes 2x plus 20 minus 3x minus 15. Don't forget, you got to distribute that negative. Combine like terms. I have negative x plus 5 all over 6 times x minus 5. Remember our trick, if my signs are just opposite of what I want, I can factor out a negative 1 and flip those signs. Cancel x minus 5, x minus 5, and that fraction boils down to negative 1/6 when you combine all the like terms. Now when we get fractions in fractions, we want to treat them separately. So first, I'm going to make this into a single term. So make the denominator into one fraction. And we need to do that by making a common denominator. So 1 over 1 can be easily transformed into b over b. So my numerator is 1 over a plus 1 over b all over 1 minus b over b. Now I'm going to go ahead and think about this numerator. The least common denominator of the numerator is a times b, so this fraction will get multiplied by b top and bottom, this one by a top and bottom. And so what I end up with is b plus a all over ab all over 1 minus b over b. So dividing means multiply by the reciprocal. So that means I have b plus a over ab times, do the reciprocal of this bottom fraction, times b over 1 minus b. And since we're multiplying, we don't have to worry about common denominators. We can go ahead, and if I have all multiplication, I can cancel. And so I end up with b plus a all over a times 1 minus b. And I can leave it in that form. So this is what we did. Before you can change the division bar, before you can change it to multiply by the reciprocal, you must combine the fractions to make one fraction in the numerator and one fraction in the denominator. So you basically have 2 mini problems to do, and then you can go ahead and use your multiply by reciprocal process. And that is all that is in today's lesson.